Welcome everyone to another do-it-yourself video. You probably have seen my quite vintage 32-bit SPARC systems, where the Sun SPARCstation 2 I only got really booting and working with Linux recently, like last Christmas or so. And the Sun IPX board I got in this bare non-working condition, and I only recently got live signs out of this and sorted all the memory and VRAM and also 13W3 frame buffer stuff out, so you may want to watch these videos first in case of. However, I don't have a case for this, so I certainly do not want to swap the power supply with the SPARCstation always. And inspired by this ATX to AT converter cable that I use for this regular PC vintage board videos, I thought I make a similar adapter cable for regular PC power supplies. While I couldn't be sure what connector it is, I thought Sun would not use something that outstanding fancy. And while obviously an ATX does not fit in there, I could test this with PCI Express connectors. Obviously I did not want to use two PCI Express connectors that may have fit in if I cut them slightly. However, this is error prone and I did not want to accidentally swap them and then destroy the board. So I went ahead and ordered brand new Molex connectors. As I was hoping, I could not really find this in the internet because of course all the Sun people use only Sun original parts and such, and very few people solder around here. So these are regular Molex connectors that fit in there. So in this way Sun was a little bit more advanced, given that at this time PCs were still using this really annoying AT connector things that were often not even really coded, so you could on many boards reverse them and set the board on fire. And PCs with ATX some years later used a nearly twice as large connector with nearly twice the pins. For all your Sun SPARC tinkerers, this is a regular adapter, and I ordered because shipping costs were higher than this. To get the per part shipping cost down, I ordered a handful of those. And today we will make an adapter, and I also ordered two. Those, for some reason, those were more expensive. These are the same ATX adapters that plug into the other side of an ATX cable, and as those were way more expensive for some strange reason, I only ordered two, cheapskate as I am. However, I thought these are not so necessary, so if you want to solder something like this yourself, you do not necessarily need to have this fancy adapter. You could directly fit this to an AT or ATX power supply. The voltages I will show in a minute, and we will also measure them just to double check, just in case, because we certainly do not want to set this Sun IPX board on fire. Then I would be really sad after all these efforts for this. The voltages are the same as PCs, so this is mostly 5 volt, 12 volt, minus 12 volt for the serial ports. First I worried that the Sun board would use also minus 5, like the old AT boards on the PC side, but thankfully it doesn't. So this means we can get away with any recent ATX power supply, and I hope I may have a nice idea for a case for this. Not needing this negative 5 volt line helps, of course, and it has a power good pin that signals that the power stabilized from the power supply, and this should be exactly the same as used as in AT and ATX power supplies on the PC sides. So we can just connect the 5 volts, the 12 volt and the negative 12 volts, and obviously the ground pins and the power good signal, and should be good to go. The only thing, of course, is if you use a ATX power supply, you need such a switch to enable power of the ATX power supply, just like in this AT adapters. So time for some double checking. When electronics came with awesome field service manuals, unlike on Macs where you need to rely on Chinese and Russian websites to get some board views and diagrams and such, on those nice Unix machines you had all those nice details written in the service manual. They even write here there are no voltage test points on the main logic board. If you need to measure DC voltage, use the pins on the 12-pin power supply connector J0701 located on the main logic board, figure 425. And the pins with red wire are plus 5 volt, blue wire are plus 12 volt, the brown wire is minus 12 volt, and the black wires are ground. It's, by the way, also why it's probably better to always use black as ground, not as I recently used myself, blue for the NVRAM. They even give you the acceptable ranges for those. So let's quickly double check that this is what we get, and then build such a nice Molex connector for ourselves. A little bit hard to get in there though. So this is 5. It's nicely grouped anyway. This is 12. This is minus 12. And here is power good, I think. And this is 5 volt. Yeah, power on reset is this pin. This is what I was not sure about, if this is like on a PC constant 5 volt. But it sure looks like this. Also makes sense that the power good signal is coming from the power supply as long as the power is really good. As even on the PC, at least for ATX, it's specified that the ATX power supply should monitor the voltages and only raise the power good signal after some milliseconds, measuring all the voltage rails and making sure all of them are in spec. So I think this was all nicely sorted anyway. Let's get to crimping the Smolex connector together. Of course you can just use brand new cable, however, as this power supply burned through the other year, I still had it in the basement for recycling material. So I will reuse this cable. Then I also have here a power supply thing for floppy and hard drive, and also all the cable color coded, as we do not have so many colorful cable here in stock. If you ever wondered how a power supply looks inside, this is how. This one I find myself a little bit low quality. This was some specific silent model. Had I known how low tech it is, I would not have purchased it, but yeah, plus some dust from maybe 5 or 7 years of server operation. This is, by the way, what I meant with PCIe and such connectors fit in there, because this kind of half add-on ITX fit into some here. And I think this 6-port PCIe additional power of the newer fitted here exactly in this tree. This is why I thought this must be a regular Molex. But as I said, I rather use a new full-length one to avoid tucking it in wrong. Yeah, I will probably not try to get those out. I guess it should be possible with some needle or something, but this is too much annoying work now. I will probably cut it somewhere here, that in case of I can theoretically use this and then use the remaining strings here to have some reasonable length adapter and some left over for future tinkering. So I sorted what we need. 4 times red, 4 times black, 2 times blue, so here not really 2 really blues, so blue and something, and brown. Yeah, so now cutting and crimp. With the right tools it may be enough to just crimp those, but I don't have the right tools and I don't want to risk that they slip out there eventually, especially trying things, testing things, pulling this whole Molex connector in and out. So I will solder them and then crimp them just to make sure that it really lasts and doesn't come off loose. If you solder this, you want to make sure that solder is not running into this channel that is connecting to the other side of the plug. This is also why I hold this here with an angle towards the floor, that the solder is not running in. But obviously for the other side of the adapter you need, one side is this more female kind of type and the other side is a more male kind of type. Maybe I could have ordered a slightly smaller size. I just realized that these are really long. This will be a little bit annoying too, but okay, it's actually not so bad. Obviously with a real tool for this it works better, but of course do it yourself, you can probably get away doing it like this. And then, does it matter how we plug it in here? Yeah, it does not fit so nicely if it is not that well aligned, but now it clicked. First came +5, then ground, and so we will continue. Maybe they are meant to be soldered after all. Even with a very strong tool pressing it together, I have it hard to believe that this cable holds there and has good contact without soldering it. If you're an expert in this Molex connectors, let us know in the comments below. So 4 times 5 volt, 4 times ground, and 2 times 12. The blue wires are plus 12, good, so plus 12. For a moment I thought I have chosen the wrong color. Only one is blue, the other is a little bit blue-greenish. This is what we got from the ATX power supply we had there. So it starts to look nice. Okay, just checking with the ATX specification on Wikipedia. Actually, maybe I should have had another look on this before we soldered, because there on the PC side yellow is 12 volt, which may be also slightly nicer than blue actually. Yeah, black is ground of course, and 12 volt, I wonder if I know it's of course not very nice to get them out again. If you repeat this, you probably do not want to follow the Sun logic board specification and instead use the PC colors, and you also have more matching wires actually. You probably also only want to try this at home if you're a little bit familiar with electronics, and don't sue us if your power supply or vintage SPARC board burns through. By the way, regarding automation, how much do you think would the power supply cost if an actual human would sit there and solder each power supply pin manually? So that is it. I quickly check if we have enough ground pins for the switch, because the ATX power supply only turn on when this power on signal is grounded. So like with the ATX adapter, we need this mechanical switch, so I just check if I need to solder an additional wire here for the switch in one of the ground pins, or if I can use another ground pin for that. As you can see, we have enough ground pins, so I do not need to solder another one. We have here in total 6, probably 7, and we only need 4. So I will use them here in the middle also, and use the one next to the power on line here for bridging this with the switch. So this crimping thing actually takes nearly the longest. Let's sort this into the other side of the ATX adapter. So I've sorted most of these cables in. Take your time, it's really easy to mix this upside down and such, and I will also measure all the voltages before I plug it into the SPARCstation. One small problem though, I think I earlier said and checked that we have 12 volt lines, but unfortunately this is the next 2 pins of this optional connector thing. So we only have actually one 12 volt line, so I will unsolder this and solder the 2 12 volt lines on this one pin. And as I said earlier already, the next time I will use the colors of the ATX connector, as it's much easier to follow those, than especially when you compare it with the power supply that you may have already. So the moment of truth. This is an adapter. Oh wait, we also need to switch. Okay, one more second. The switch pin here, I use the switch of the old power supply, but later I will also get some new of this plug things here, like on the pre-made ATX one. So power on. Nothing is burning yet. So let's see. We have here ground and 4 times 5 volt. Right now it's off. Let's switch it on. Now we have indeed 5, 5, 5, 5. Let's check all the other ground pins. 5, 5, 5. So, and then we have 2 times 12, 12, 12. Here we have minus 12, and here we have power good. So I guess we can plug this into the SPARCstation IPX board and see if it boots or catches fire. And and we have the SPARCstation IPX indeed fully posted and ready to boot. Obviously we have no storage attached and also no network booting adapter there today, but it is fully working and good to go. And I think this is of course a much nicer solution. Obviously it doesn't look so nice now, but this is only a first test setup. I will use it with another power supply. My other spare power supply is in use right now, so I use this half-empty case, and certainly it's much better that we can just connect it to a power supply and not need to rely on the SPARCstation 2 that we need to open each time, and also stress the cable of the SPARCstation 2 that we need to pull out. And this is really tight. The cables are only 2, maybe 3 centimeters long, so it's really tight to pull the cable out of the SPARCstation 2 and plug it in with the board laying on it into this. So first of all, it's of course super compact with graphics integrated on the logic board, and also the higher density memory, of which we have here 32 compared to the just 16 of the SPARCstation 2. And in general, it's of course always nice to have a fully independently working second board in any case to work with and such. So next we will also build a nice case for this. I have already a nice idea. However, this has to wait a month or two. First we need to do some other interesting stuff. So that's it for today. I hope you learned something. Give it a thumbs up if you liked this video, and don't forget to subscribe for all the next surprising videos to come.